Okay, so can you give a brief interview about like who you are, years of experience, what you're interviewing for, stuff like that?
Yeah, hi, my name is Tarun. So I recently graduated from my master's degree in data science at Arizona State University. And I'm currently looking for full-time opportunities, and I'm having around 3 years of work experience as a Java developer.
Okay, cool. So I guess you're doing this in Python because it's easier to do Python leetcode for you?
Yeah, I'm comfortable in doing programming in Python.
Okay, cool. Okay, so the first question we're going to have is you're given a integer array called apples. And basically what I want you to do, so here's an example. Let's say we have something like this. I want you to divide this into two groups such that the diff between the groups is minimal. Okay, so for example, we can divide it into like 2, 3, 4, and 1 and 7. And so one would be 9 and the other would be 8, so you would get this answer. So just divide it into two groups. Then basically you just return the minimum difference that you get. So in this case, actually, it'd be 1.
Okay.
And yeah, feel free to ask anything you want to.
Yeah, sure. So basically the question is we have given an array of apples and we need to divide the main array such that the difference between the two sub arrays should be minimized.
Yes.
And here what should be the length of each sub array? It should
So
be
I
at
don't think
least
that's
one.
relevant to the question. Like they can be whatever you want. So like if I have a big number and all the rest add up to the other one, then it can be whatever you want. It's just we're trying to minimize the difference, and they can be whatever you want.
Okay. So from the example, so the first case, like so we need to return the integer, right? The
The
minimum
integer, yes.
difference.
Yeah. So you don't need to have the group. Just return the minimum. Yeah.
Okay. And yeah, I need to split it only into two groups, or
Two
not
groups. That's
more
right.
than two. Okay. So basically, the brute force way is like maintaining two queues, like, and what I'm going to do, I'm going to iterate through every apple.
Uh-huh.
So, for example, considering the given example, so initially we are at, I'm just trying to. So when we are at, so I'm going to iterate through apples, and I'm going to add it into the queue, like thinking that maintain two queues.
Okay.
And whenever I'm going to add it into the first queue, I'm going to check like if the already present element is greater than the current apple. For example, we have here 32741.
Uh-huh.
So let's define consider these two. So initially I'll be at 3, so I'll add it to the 3 here.
Okay.
And here we should get the 2, 3, 4 and 1, 7. So the output can be negative, or like negative also.
Yeah. So you can have negative numbers if that's what you're asking. but you still want to have the so the difference will never be negative, right? Like the difference, you just do like the absolute value, but the numbers can be negative.
Mhm. Okay, the numbers can be negative.
Mhm.
Okay. So here in the first case, we have 2, 3, 4, and 1, 7. So I need to split the apples. So what I'm thinking, like, so initially I can sort it like, if I sort it like, I will get all the in the sorted order like 1, 2, 3, 4, and 7. Checking which approach I need to. So if I sort it, I get like this, and I need to split. I'll try splitting like from each side. Look, so I'll consider 1 and 2, 3, 4, 7, and as well as 1, 2, 3, 4, 7, 3, 4, 7, 2, 3, 4, 7. But here, like, I think this is not going to work because even I'm following the greedy approach, but uh, from the above example, we need to split because here you can say like 1, 2, 3, and 4, 7. It's not matching. Like, so divide this into two groups. I'm just thinking about how to approach it.
So one thing here, I think maybe I need to clarify is the groups don't need to be um, adjacent. So like if you actually look at the example I gave you, like we pick numbers that aren't right next to each other. So we picked a 2, 3, and a 4, right? So you don't necessarily
Yeah,
just
yeah.
like okay. You
That's
wanna
what I'm thinking. Like, how can we, like, it's like subsequence. It's not
yes.
uh, sub array.
Uh-huh.
It's not going to work. So at every apple, I have like three. I have two conditions. Like if I having two substrings, for each apple, I have two choices. Like whether I can add it into first one or the second one.
Mm-hmm.
Yeah. So for example, consider above example, for at every index, I'm going to add like for every index I'm going to add like going to in a recursive way, like I will add 3 over here. So for each subarray yeah, for each apple I'm going to check like whether I can add over here or I can add over here. Like it can
Okay.
be either add in at least one subarray,
Mm-hmm.
and I'm going to recursively like add like so I'm going, so for example here I just added 3 over here and then 2 over here. And if I add 7, so at each state, like I'm going to compare like the difference between both the subarrays. So I think I need to maintain the sum also, sum of each subarray, and I'm going to maintain a global variable uh, minimal sum, and I'm going to compare uh, when I iterated through the end of the apples, like if the length of the apples like if my current index is at n, which is length of the apples, so and I'm going to get the sum of both the subarrays, and I'm going to uh, get the minimum value. So it's
Okay.
like a DP approach, like
So okay, so if you do it that way, like you're basically saying like for every single one you put into one or the other, right? And then you'll
yeah.
get the difference, and then you'll get the min. Okay, so what's going to be the time complexity of that?
So if I do that, like it will be 2 power n, because every apple has two choices,
Mm-hmm.
but I can reduce it by using memoization. So I'm going to define the state such that so I'll store the state in such a way, if I'm going to compute it again, it will just return from the memory which I saved, like, so then it will be, I think, linear time log n, sorry, n.
And okay,
Yeah.
okay, so when you say you'll save the state, like yeah,
So
can you
yeah,
go over like what the state would be?
yeah. So here I'll follow the TP approach. So here the state is I need to get the index, so it will be I, and also as I'm going to maintain two variables, sorry, two subarrays, which is subarray 1 and subarray 2. Yeah, I think subarray 1.
Okay, so you have two subarrays, you have a state I,
Yeah,
and
I'm thinking, should I add like any other constraint to consider in the state?
uh-huh.
Because at every index, I should definitely need the index, but uh, at every index I'm going to recursively, like, either I should add into subarray 1 or subarray 2.
Uh-huh.
I think here index I is enough for the state, like in order to
Okay.
get the.
So, okay. So basically you're saying you can have index I and then you can add it to one of these two subarrays. And then they will give you like the min. It will return the min or something. The min difference from here. That's what you're saying?
Yeah.
Okay. Uh okay, yeah, and then okay, yeah, I think that sounds good to me. Um okay, yeah, if you think that works then and this
But
can be O of n, we can try to code it.
yeah, but I think, like, I'll try with the, like, index as of now, like,
Okay.
but if anything occurs like in the middle of the, I will just change the state. So yeah, can I write the code?
Sure.
Yeah. So I'm going to define, we will have apples. So I'm going to get the length of the apples first. So as this is a recursive call, I'm going to use the DFS. So this subarray 1 and subarray 2, these two are, I can consider it as global.
Okay.
Yeah. So what I'm going to do, I'm going to, like, check when I should get the, when I should do the difference. I should do the difference when my index is at the last, like if I w equal to n, I'm going to do the difference. This is the base case, like, so I'm going to get the subarray 1 sum.
So if you do this, by the way, this isn't like memoized, right? Like you can't have this memoized. Um, because you're inserting things into arrays, right? Like basically, so this wouldn't be like O of n, which is fine. But yeah, I just want to clarify that.
Yeah, I think I don't need the arrays. I need only the sum of the subarrays, like, because at the end we just getting the difference. So I just need two variables, like subarray 1 sum and subarray 2 sum.
Okay.
Yeah, so yeah, I think this is the state. So in the state, I need both the subarray 1 sum as well as subarray sum 2. So
Okay.
this is going to be the state. So if I is at the index, so what I'm going to do, I'm going to return the absolute value of both subarray 1 and subarray 2, subarray sum 2. Uh, as we talked about memoization, I'm going to, or else if the current state, like if I or so, and if this is in the memoization we already computed in the cache,
Okay.
I'm going to return it. So now coming to the main part, like the recursion step. So here now what I'm going to do, so we have two options, right? So like I can consider sub subarray 1 or
Mm-hmm.
consider subarray 2. So if I consider subarray 1, my state will be refs I plus 1, and I'm going to increment the subarray sum with the current apple,
Mm-hmm.
but I just use the subarray sum like this. Or else I can do I plus 1. Uh, Now I'm going to append into the subarray 2. So here I'm going to do apples 5. So here we got two states, like uh, sorry, two options, which is adding into the first subarray the current apple or adding into the second subarray. And I'm going to take this both. What can I name this, like add add to first, add to second. So from this both, should I get like, I should get the minimum.
Okay.
Before returning, I'll just take add to first and add add to second,
Mm-hmm.
and then I'm going to return the Sure. So here I'll start with 0, uh, the both subarrays,
Mm-hmm.
and I'm going to return it.
Okay.
Yeah.
Yeah, if you're good with this, maybe we can try some examples, because I think it's going to be pretty hard to draw your own with like a big thing. So I think you can just test it and see how it
Sure.
goes. So you can just hit run whenever you have it.
Yeah, sure.
Oh, why did you have a self here, by the way?
Yeah, sorry. Yeah, initially I thought I'm going to store the subarrays, so yeah, I just added that.
Okay, got it. Okay, so that seemed to work. So do you want to create some test cases?
Yeah, sure.
Yeah. Okay,
I'll create some test cases.
sounds good.
Uh, oops. Let's try with the negative numbers. 2, 3. I'm just giving this random variables. Let's see first.
Okay.
So
Okay, so you got one. I guess maybe we could try. Do you know how this would be one, or maybe you could try something smaller that you know for sure? Uh, yeah, I'm not sure exactly. Like, I guess there's this would be like negative. Yeah, maybe try something smaller, so we could verify for sure. Unless you know how this would get out of a one. Yeah. Okay. Okay. I meant more with like this negative number example. Like maybe we can try something that you know what the answer would be, and then like
okay.
because do you
Okay.
know how this would be one? Like I'm
Mhm.
not seeing it off the top of my head, so that's what I meant.
Yeah.
Okay.
So let's consider -3, -2,
Mhm.
as well as 3, 2. So if
Okay.
I consider this case, it should be 0,
0.
right?
Yeah, I agree. Okay, that's fine. Okay. Yeah, I think we're good. I think we're good to move on.
Yeah.
Yeah. Okay. So let's move on to the second one. And time-wise, we have about 35 minutes left. So, okay, second one. You're given two arrays. So nums1, nums2. You're also given an integer k. So let me give you an
Okay.
example. Okay. So something like this. And basically what I want you to do is pick k pairs from nums1 and nums2. So what I mean by a pair is you have to pick one number from each of them. So pick one number from each of them. Now, the rule is if I pick index I for pair j, I have to pick a bigger index for pair j plus 1 all the way. So like, let's say for my first pair, I pick this index from nums1, or actually this index from nums1, then I can't pick this one for my second pair. So the pairs in each array by themselves have to be in increasing order, but they don't necessarily have to be the same index. So like you don't have to do 1, 4, 3, 5, 2, 1. And basically what I'm trying to maximize here, maximize the product of each pair. So basically what I want you to return is the sum of all products. So in this example, you would actually pick 3 and 4, and
Okay.
then you would pick 2 and 5. So you see how like I
Okay.
picked a 3 for the first pair, so I
Yeah.
can't pick a 1 here.
Yeah.
So if this was like 9, I can't pick it.
Yes.
But they don't
Yes.
necessarily have to like line up. Yeah. Feel free to ask anything you need to.
Okay, so we have given two integer arrays, and we need to find k pairs from both the arrays. So we have the constraints also, how we need to pick the elements to form the array. Sorry, the subarrays, and we need to maximize the product of each pair. And we need to get the sum of the pairs, the
Yes.
sum of all
Sum
products.
of all
Okay, sum of
products. Yes.
products of. Okay, so I just want to check, like, from the above example. 1 second, I just. So we have given two numbers, integer 1 and nums2, maximize the product of each product. So here the size of nums1 and nums2 are equal.
Yes, so nums1 and nums2 will actually, no, they don't have to be equal. So they don't have to be equal, but you will always have enough items to get enough pairs. So basically,
So
the
I mean,
length of nums1 does not have to be equal to length of nums2, but the min of length of nums1 and nums2 is going to be greater or equal to k.
okay, so we should always get k pairs.
Yeah,
That
so
is
you have to
guaranteed.
get k. You can't skip. Yeah, you have to get k.
Okay. And is do we have negative numbers for, like,
So
the
you
numbers,
can
or
also
only
have
the
negative
positive?
numbers, yes. It can be positive and negative.
Okay. So basically, the brute force will be like, uh, mm, what I'm thinking, like, so for each, consider, mm, yeah, for every pair, we should have, we have only two arrays, right? Not more than two, like, because if we have k equal to 3, that means the nums, there will be also nums3, or just only two
So
arrays.
basically, like, what? Sorry, can you ask that one more time?
Yeah. So the nums1 and nums2, the length, like the number of arrays, is it related to k? Like
No,
if I have k.
you will only have 2 arrays and k. So
Oh,
basically, this is related to k. So
okay.
k can't be bigger than the length of the min length of the array. So you'll always have enough pairs to get k. But you only have 2 arrays ever. It's just always 2.
Okay. Okay. Gotcha. Yeah. From the above example, let's just write it down.
Sure.
So if I consider, like, at index I have three options to consider, like, for every index. So when I'm considering a pair, like, for example, for the first pair, I'm just thinking about the brute force way first. So at for every index, I'm going to match with every other index of other number, like, so 1 4, I'm going to get the product 4, and 1 5 1 1. So that means here
So
I
that
got
wouldn't
one.
work because if you match 1 1, for example, now
Mhm.
you don't have any more pairs to pick because they have to be in increasing order. So like if
Uh,
I pick this for the first pair, I don't have anything else I can pick.
okay. So I need to pick in such a way that we should maximize the product of each pair. Get the sum of all products. So for each pair, how can I maximize? How can I choose two numbers such that the product is maximized?
Mhm.
And here the index matters because I can't randomly get the numbers.
Yeah.
Uh, just let me think
Sure.
for a second. So we have 1, 3, 2, and as well as 4, 5, 1. So if I consider here, we need to pick 3 and 4. 3 and 4. Is there any path? So 1, 3, and 4. So I'm thinking like, for example, if I consider like the first number, so I have options like I can consider 1 at index 0. I can consider index 0, but at index 1, I can have options like 0 and 1, and
Yes.
index 2, I have options for 0, 1, 2.
Yes,
So
but you also need to make sure you actually get
make
the
sure to have it.
pairs.
Okay.
So like if for 2 you pick something, you won't have enough pairs. Like if you
I
skip
can
these, you
pick.
won't have enough. So you need to
Yeah.
you need to handle like getting enough and then yeah, making sure they're in increasing order so they can't be all over the place.
So 1, 3, uh, 3, 2, 4, 5, 1. Which period? So here, like, sum is the product of each pair. So consider this example. We have 3 and 4, which is one pair, and 2 and 5. Here you can see it is getting the higher, and this is 4, this is 2, this is 5. Like I'm thinking about like maintaining two queues for nums1 and nums2. Like for example, uh, if I have 1, 3, 2, that means my queue, I should get. So this k constraint is blocking me like choosing like
Well, for example,
value.
I guess to unblock you a little bit. Like let's say you picked some stuff, right? And you're trying to maximize the result. So something you could do is be like, well, if I didn't have enough, I could just say it's like, I'll just return something that like I will never pick, like negative infinity or whatever, right? Does that help?
Mhm. So like, so if I pick 3 and 5 uh, for the first pair, for the
Mhm.
second pair I can just pick 2 and 1, but that is not the answer, like, because I need to pick 3, 4 first and then 2, 5 next. Yeah, this is also related to like for each. So when I consider number one, so I have three options:
Uh-huh.
1 4, 1 5, 1 1. Uh, Based upon the previous number one, for example, uh, so what is the length of the numbers, like numbers one and two?
So you can
Is it
assume it fits in an integer and it's like decent size, so it can be pretty big.
okay? So yeah, I'm thinking like, for example, if I compute for each number, I'm going to get the uh, every number in the nums. For example, if we get 1 4, 1 5, 1 1, and also I can skip this also, skip this number also.
Yeah, so in that case, that would be like for every number, you'd get all the numbers in the ones, and you would skip it, and you would try everything. So it would be the time complexity of that.
Yeah, it's like for every element in the nums one, we are iterating to every other, like the entire length of the nums two. That means it's n square.
But we'd have to like try it and then like move on to the next number and try and do some kind of backtracking thing, right?
Ah, yeah.
So that would be like
That
n to the
yeah,
n, not n squared or
yeah,
something.
yeah. So length of numbers. I need to maximize product. So 1 3 2 4 5 1. If I choose one, we have 4. Consider this example, like if for every index 1, I can only choose up to th- that particular index. Consider like that. For we have 1 4, then I can't move to the next state. So then it will be 3 5. Okay, 3 5. So it's like a tree structure. Like if I consider 1 4, if I consider 1 4, then I have options for trees like uh 3 5 and 3 1. But if I skip 1, my tree has options 4 5 1. If I consider 3, it's 5 3 5 of each pair.
Yeah, so I guess to give you like another hint, like you were saying for one, I'm gonna try all of them. The thing is though, like if you say you don't pick something, right? Like if I'm like I'm not picking this, like then you can never pick it again, right? Like if I skip this in a pair, then you can never pick it again. So does that help kind of reduce time complexity in some way, where like we don't have to look through everything for every single number?
So for example, so if I skip,
Yeah, if you skip a number, you can't take it again later on because you can't go
yeah,
backwards.
because
Yeah.
yeah, okay, yeah, that makes sense. Like yeah, I think for every pair, like 3 4 2, So that means here, if I consider like 1, 4, then I can go backwards.
Yeah, so like
And I,
if you like let's say you're here, right? You're like, okay, I'm at these numbers and I want to figure out if I want to take one of them or both, right? So basically it's like I can either skip one of them or I can take the pair.
oh, okay, okay.
Does that help? Okay.
That is for every s- like every pair, and we need to consider this.
Yeah, and
Yeah,
like let's
just
say I
let
skip
me.
this one, then now it's like do I skip one of them or do I take this pair and so on.
Yeah, just let me try it on that. Like, just want to see like. So, for example, if we are at 1 and 4, like for example, if I consider it 2 pointers, I and 4, ij. So at every option, I have at every steps I have like I can skip this or I can skip this, or I
Mhm.
can consider the pair. So it's like 1 4 or 3 4, or just move to the next pointer, which is 3 5.
Mhm.
But I'm just worrying about like how can we choose, like we need to get at least two pairs, because if we keep going we are going to get only one pair, like we are going to get the only one product. So that,
Yeah, so what are the things you need to keep track of? One of them, I guess you figured out probably is like the indices. What's the other thing?
yeah, it's in this is
Like how
the
do you
other
know you
thing
got
is
k
like
pairs?
when I reach the end of the both the like if I is at the end and the j is at the end,
Uh-huh.
that means I don't have any options, and by that time I should got like two pairs.
Right, so how do you know how many pairs you got by the time you got to the end?
uh, because if I consider when I said like we should consider the when I'm considering the pair, that means I will increment the value, like, or else I'll maintain a variable, or I'll just decrement the k. I can't decrement the k. I'll just maintain a variable and I'll
Uh-huh.
compare with k, like if I got, because whenever I'm considering that means I got a pair.
Right. Yeah, so you're going to maintain a
Yeah,
variable of like how many pairs you have or something?
yeah, yeah.
Okay. Okay, and what would be the time complexity of that?
I think here we need the memoization also, because uh, no, I think we are not going to recompute, because we are going in just we are not going backwards. We are just going, because at every index, yeah, this will be hmm, I think n square, because for every index we are going to consider option, like at every index I we are going to consider either skip it. Yeah, I think it's n square.
Okay, okay. Do you want to code it then or do you want to write anything else? I think we have about
Yeah, I just
15
want to
minutes. Oh
try
yeah,
run it
sure.
before, like,
Sure.
so for example, if my I is at 1 and j is at 4, I have options to skip. So like I'm just, okay, how can I get the maximum product
Uh-huh.
each? So here we have 1 4. If I consider 1 4, or else I skip it, we have 3 4. Yeah, else it will be 1 5. So I'll get the maximum from these three choices. Yeah. Can I? So actually, so initially my I pointer is at 0 and J is at 0, right?
Uh-huh.
So I'm having three options, which is skipping I, uh, or skipping J,
Mm-hmm.
or considering the pair. That means
Yep.
we should do both. So I'm going to get the maximum from these three, because this. So if I consider this as a pair, this is, I'm not considering this as a pair, but here I'm considering this as a pair. But in the future we will do the recursion. Yeah, this is also you can solve by using backtracking. Yeah,
Okay.
you getting what I'm saying? Like,
Yeah. So here, so you said it's n squared, right? So we have an I and a j, but how do we know how many pairs
yeah,
we have? Are you going to do backtracking with that?
no, I'm going to plus 1j, because here this is the case where we are considering, right? Like, okay, then I need to maintain another variable, number of pairs.
Mm-hmm.
Number of pairs is 0 here.
Yep.
Here it is also 0, but here 1. The pair is 1.
Uh-huh.
But uh, if it is 1, like I'm just thinking like, okay, if I consider like 3 and 4, 3 and 4 is the case. Okay, I
Uh-huh.
got one pair. Now, like, I'm going for 2
Mm-hmm.
and 5. So here 2 and 5, what are the three options? Uh, I can skip the 2,
Mm-hmm.
or I can skip the 5, or I can consider this pair 2 and 5.
Right. And when you skip the two, if you skip the two, then you should say, I don't have enough pairs, so then that should never
I,
be the answer.
yeah, that means we need to have a base case, like
Uh-huh.
if I or j is greater than the length, then
Uh-huh.
I'll just return 0,
Okay.
because we need the maximum product.
Okay.
Yeah, that's what I'm thinking.
Okay. Yeah. Do you want to code it?
Yeah, sure.
Okay.
So should get the maximized product of each pair. So just remove max sum. So we
Okay.
have this one, this 2.
You have a K as
Uh,
well.
oh, sorry, yeah. Okay, as well. So I'm getting the length of both the. So will it be empty? The nums one or nums two?
So it can only be empty if K is 0. Like you're always going to be able to pick K from
Oh,
there.
okay.
Yeah.
Yeah. Uh, so I'm going to keep track of the variable size a. I say k. Uh, I equal to 0. I equal to 0. If I is, so here the base case is if I uh, double equal to if I is 1, or j reaches the limit, I'm just going to return 0 for that case.
Okay.
Or else what I'm going to do, I'm having three options. First is I can skip I, and I'm having 0 plus 1 j plus 1. Here I can rename this current pairs. So yeah, like, but maximize the product of each pair. So here what we are trying to get is
The sum of all the products of each
some
pair. Yeah.
sum of multiple. Okay, so if I consider this, that means it is a pair. So that means here I can do uh, product of sum of maximize the product of each pair. So I can do like nums1 of I into nums2 of, say, I.
Okay.
Skip j, or else I just consider the pair.
Mm-hmm.
So here we are getting, we are tracking, like we are getting the pair here, like which is the product. Here we are getting one pair, right?
Mm-hmm.
For the next pair we are doing this like I plus 1 j plus 1
Mm-hmm.
and current pairs. And also I need to check like if current pairs should be less than current pairs. I need to prune that tree, like the current pairs is already reached. I can't, like it's already k,
Mm-hmm.
then I can just prune it
Okay.
because yeah. uh, so here we need to get the maximum. So skip I, skip j, or consider will start at 0 0 and current pairs is 0.
Okay.
Then just return yeah, like the current pairs. I'll skip it or consider it. If I consider it, I'm going to this is one pair, and then I'm going to check for the other pair. Skip, consider. Yeah, I think
Okay. So here, can we? So here, basically, like, do you think we'll recompute anything or no?
uh what do you mean recompute? Like
Like, for example,
a rework?
let's say we have four pairs. So let's say it's like
Okay.
this. Um. So one option is like take the first pair, right? And
Mm-hmm.
then we're gonna come to the second index, and
Mm-hmm.
then so basically I is j, uh, or sorry, I is one, j is one, k is one, right?
There's one.
Okay.
Yeah.
Now let's say we skip the first one, and we or okay, actually sorry. So yeah, let's say we go here, then we skip. So basically I will be two, j will be two, k will be one, right? Now,
Yeah.
what if we skip the first one for both of them, right? And then we take the second one. We're going to get to the same. So we skip the first one, we take this, and we come here. We're in the exact same place now.
Yeah.
So here, like, what would be the time complexity of the solution?
So you're saying like we can do memoization for this approach because
Yeah.
like I think we are recomputing again and again.
Mm-hmm.
So yeah, if we add like cache memory, like so what the current pairs? Yeah, we can just use this. If the current state we already computed,
Mm-hmm.
we are just going to return it.
Okay.
And before returning it, I'll just store it.
Okay.
Yeah.
Do you want to try running that on the example?
Yeah, sure.
Sure.
3 2 4 5.
Cool.
Skip.
Okay, so we got. Oh, let's comment out all of these real quick. Okay.
I don't know. Here it is showing like cannot be.
If you run, oh, let me see. Oh, it
I
says
think
you have an error. Do you see it?
okay.
Okay.
Here for this three options, like I think max is going to take only two arguments. I think.
Max will only take what? Sorry.
No, I'm just like confused. Like why this max is skip? Why this is giving me an error?
Oh, it
Skip
is really.
four,
I'm
five.
not seeing the same thing as you are. Oh, okay. I see. That's weird. Oh, so it says. I see. Um, file DFS unsupported for. Where is it?
Yeah,
Type
yeah. So
error
here
on
I
line
just hit
80 right here.
current.
I see.
So if current pairs is
Oh,
k,
oh yeah. You never returned. That's probably why.
uh,
Let's see if that worked. Okay, yeah. It looks like you got something now. Okay. So let's see here. So that was 22, right? So can we try? Can you think of any more test cases?
so is it right? Like 3 4 12,
Yeah,
2
that
2.
is right. Yeah,
Oh, okay.
because you would
Just
pick
one.
3 and 4 and 2 and 5, which would be 22. Yeah.
Yeah, yeah. So let's try with. Can we consider minus cases also, right?
Yes. Yes. And try to pick examples where like you know what the answer will be.
Yeah, that's what I'm making sure as of now. Like
Okay.
so, -5 -2. So for example, so I think here it will be if I it is 2 -5 into -3 into 2, right?
Mm-hmm.
Because 2 5 10 3 6
Yeah,
to
it'd
the
be 16.
16.
Mm-hmm. Okay. Um. So I think I know there's an error, but I'm trying to figure out how to. Okay, I think I have an idea. So why don't we try this one? And you can let me know if you figure out what the error is. So what should this be?
So here we have negatives.
Uh-huh.
So here if we consider 2 5s are 2 2 and 2 and minus 5 will be uh, minus 10, right? So 2 and 2 is minus 4.
Yes, I think here the answer would actually be, yeah, -4. Yeah. So let's try it.
Minus 4? No, how it will be minus 4? Because if we consider 2 and minus 2, it will be minus 4. And for 3, we can do 3 and minus 1,
So you're trying to
which is
maximize,
minus
right?
2. Yeah,
So it
but we
would
need
be,
two places.
right. So you'd get 1 and -2, which is -2, and then you'd get 2 and -1, which is -2.
Okay.
So it should be
Yeah, we are
-4.
considering the 1 and minus 2.
Mm-hmm. Okay.
Okay.
So let's see what we get. And we'll probably get 0. Yeah. So can you figure out why that is?
So here, just let me check. The pair is 1 and minus 2, and the other pair is 2
Mm-hmm.
and minus 1, right?
Yeah. Yeah, I mean, either way, you know it's not 0. So
I'm just like, so here it will be minus 2 plus. So maximize, okay, maximize. So what if the product is negative? So if the product is negative here,
uh-huh.
so these both products are negative. So if we add it, then it is going to be uh, 0, right?
No, it should be
So we
-4.
don't consider, it should be, okay.
Because if you're maximizing, so if all your answers are negative, you just pick the least negative number, right? Like if every pair has a negative product, you would get a negative
Mhm.
answer, and you have to pick them. So
Yeah.
can you figure out where in your code that was a mistake? That like why this is causing this?
Yeah, here I'm getting the maximum value. This is considered like, for example, we're having all the cases are positive.
Mm-hmm.
But when you said like all the cases are negative, then the maximum should be the minimum, right? The maximum.
Yes, like the minimum negative. Yes. Well, it should still give you the maximum, basically, right? Like basically, when you do max of like if I do max of -2 and -8, I'll get -2, right? Something like this. So it should still like work the same way. You just have like a bug. I guess so. We're actually like 5 minutes over, so I think we can actually stop here because I also gave you an hour. So let's just do
Yeah.
feedback here. So what do you think you did well, and what do you think you need to improve in?
Yeah, I think for the first problem, I got like initially I thought like it is DP and the states and all, but I was just confused with the state initially.
Uh-huh.
But after that, I got it. Like we
Uh-huh.
need to maintain three different variables. But for the second one, I tried a lot. Like I didn't get the proper intuition, like how I should go, like how I should approach the problem.
Yeah.
And also in my mind, it is like, even though it is a TP problem, in my mind is like, you already asked me DP problem, so you're not going to ask DP again. so so that's why I didn't think in the DP manner. But
Uh-huh.
yeah, I think
Okay.
that's the thing.
Yeah, so for the first one, I actually wrote DP doesn't like work, but I think DP does work the way you had it. So basically you have to recognize that I think there were a couple things that you did okay and a couple things you screwed up. So the DP was okay, but the thing you screwed up was you said it was linear time. So I think you have a hard time figuring out time complexity and like what things look like for DP, especially with like multiple states. And we kind of ran into this twice. So for the
Yeah.
first one thing you could have done was backtracking. So basically, like you could have, because you can't like the way you have it here, this wouldn't be n. Like sub one sum can be like 2 to the n 2 to the n things, right? Does that make
Yeah.
sense? And sub 2 sum can also be 2 to the n things. So I don't even know if like this is better than backtracking, because you can add like you can have a bunch of different combinations in sub 1, and you can have a bunch of different combinations in sub 2. So I don't even know if like this DP is gonna outperform backtracking, but either way, you thought it would be like one thing where like I'll cache something and then you like it was completely the other thing. So I think that's like the negative here, where yeah, you basically like in your what you said you were gonna do didn't match what you did. And I would consider this problem was like, if I tell you it's backtracking, I think you'll easily figure it out. So I was like, I just can't give you a hint here, because it's like easy enough
Yeah.
to where if I give you a hint, I tell you the solution. So I think that's like your main weakness in most of these is like you have a hard time figuring out time complexity, and like I need to do some stuff. How long does that actually take? Does that make sense?
Yeah. Yeah.
Okay, and then so you pivoted, but your solution does work. But yeah, I would have pointed out like, hey, I'm pivoting to this, and this would actually be, I think this is like 2 to the n times 2 to the n times n or something, the way you have it, because each one of these subset sums can be 2 to the n, because you can basically like add it or not. And then yeah, so this is going to be like a very big space, or very big time and space, I guess. But as far as the rest of it, I think you did okay. And so I gave you a like 3 out of 5 for DSA because you kind of pivoted. Your coding was fine. And then your communication was fine. Your speed could have been faster. Then your testing was pretty good. Definitely, I would suggest in the tests, if you have to run your code, make sure your tests are like you're actually testing for different things. Also, make sure when you run a test, you actually know what the answer should be, right? Like if I've thrown in 10
Yeah.
numbers and I get something, like how do I even know it's
Yeah.
right? So
Yeah.
yeah. And then for the second one, so for what it's worth, I think the first one's a pretty standard medium. Like there's nothing tricky. The second one's like a hard, but it's like an easier hard. So it's typically the level that I ask for like this kind of interview. And yeah, I guess maybe you were like, oh, he just asked DP, so I'm not gonna ask DP. But the first one was actually backtracking. You just chose to do DP. So
I thought, yeah.
yeah.
Okay.
So you definitely need to have like better problem solving intuition of like, oh, I'm getting these pairs. And because these are increasing, I basically have these 3 choices, and I had to give you a ton of hints for you to like get that. Like I basically had to draw it on the board. It's like we can either move one, we can move the other, or we can take the pair. And so I definitely think you need to get better at problem solving, because one thing I could have done was just not said anything and like let you struggle and like never get anything. And I feel like if I didn't give you any hints at all, or very minimum, you just wouldn't get anywhere. Because you were like, for every number, I'll try all of them, and then how do I know if I get the number of pairs and so on? So you need to recognize it's like, well, all I need to do is either pick one or pick a pair or move them up, and then when I move them up, I can never move them back. So I'd say even though there's like a lot of states, this is like an easier DP as well, because it's literally just like 2-pointer and then you just move down. And there's a bunch of DP problems like this. So I said your DSA wasn't super good on this one because I had to give you a lot of hints. Also, you said it was n squared, and it's basically it should be like n squared k, because I have I and j and k. So once again, it's like I think you definitely should do more DP and like, or just things that with complicated time complexity, and then figure out like what's the correct time and space complexity for that stuff, because I feel like your understanding there should be a little bit better. And then I also had to point out to you that you can cache the stuff, and you didn't realize that, which was like not great, because I had to basically show you here we can get to like the state in a bunch of different ways. The other, that negative edge case I would consider is also pretty important, because I didn't tell you the numbers can be negative. So you should recognize like, oh, if all my pairs are negative, I can't return 0. So your mistake here was here. Instead of returning 0, you just return some small number, like negative infinity or whatever. You make sure you don't like overflow to negative, but whatever. This can be like negative infinity overflow or whatever this thing is.
Oh, okay.
So that was a mistake there. So that's why you were getting 0 instead of the negative number that it should be.
Yeah, I
Yeah.
got you.
Yeah. So I said, because it took you quite a while, I said your DSA was 2 out of 5 because I had to give a lot of hints. Your coding was 2 out of 5 as well. You had like the edge case, and also you didn't cache stuff until I told you. Your communication was okay. Your speed could be a little bit better, and then your testing also. I feel like even though like I had to point out to you that negative edge case, so you want to be able to make sure you test different things. So if you try like all negative numbers, then it's going to give you a positive result anyway, right? If I try like this is kind of similar to this, so you should test like
Mm-hmm.
all negatives in terms of the pairs are actually negative and see if you get the right thing. So you should be like, this is like an edge case I could think of, and now the answer should be negative here and it shouldn't be 0. And then even when I pointed it out to you, you were a little bit confused. So I think, yeah, basically just like need to understand the problem better. So I would say overall for this like interview, this would be like a somewhere in the borderline of like lean higher and lean no higher in my opinion. And realistically, in like a difficult market, probably be the other way. But either way, I feel like for this, for your sake, like it doesn't really matter what you get. Basically, you want to aim for like a strong higher, because if you don't have that, then there's like a lot of things you can improve. And I think the main things you need to improve is overall problem solving and really understanding time complexity of your solutions. Because I feel like in both of them, you were like a decent bit off there. And then the other thing is you really want to get a solution and be confident that it works before you code it. Because if you get a solution and it doesn't work and you're like, oh, actually, I'm doing this, a lot of times you just run out of time. Does that make
Yeah,
sense?
yeah, 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 yeah.
Yeah. And yeah, I mean, I did have to search for some problems that I didn't ask before, so that was also harder. But yeah, basically, I mean, I didn't know you could do the second with a DP. It makes sense, but I think this would actually be just like a worse solution than backtracking. And I was like, well, if I tell you it's backtracking, I think it's like too easy at that point, because it's like very. I think the problem is like simple enough as it is. So yeah, so I think those are the main things you have to work on. It's basically like problem solving ability, and then yeah, making sure you understand time and space complexity. And yeah, if you said you watch like my videos and stuff, you can just watch like the problems I ask. Like anytime I ask new problems, just like pause, try to do it yourself, and then see how other people do. Especially, I don't know if you watch the people that got like the really good scores, like strong, higher, or whatever, and see like what's the difference between them and me, right? Like I'll upload this, and you can go through it, and you can see like what are they doing that I'm not, and it should be like pretty clear to you. And then like those are the things you need to work on.
Yeah, yeah.
Okay. Do you have any other questions?
Yeah, I just want to ask, like even though I saw like mostly I concentrate more on basic data structures.
Uh huh.
Nowadays, I'm going deeper, like hard and medium
Uh huh.
problems. So just want to know, like, is there any patterns? Like, should I go with any type of questions, or just go with random DP questions, like
Yeah,
in order
so
to
so
get
I
more
would
better?
say a couple things here. Like if you know you're weak in DP, then I would focus on DP questions. If you know you're weak in
Yeah.
like one category, just find decent level questions for that category. Because if you do two easy questions like climbing stairs or something, you'll
Mhm.
be able to do
Yeah.
those. But so I would do a couple things. I think I linked this thing. I can link it to you, the LeetCode difficulty rating thing. So you can look at this, and you can. There's also a LeetCode extension that you can Google that will tell you like the difficulty of the problem, and you can literally just go on like NeetCode or whatever, look up the DP problems on there, and do the ones that are like reasonable to difficulty that you haven't done before. Just do like 10 or 20 of those, and you'll get a lot better. So that's how I would recommend learning a topic that you feel like you're really weak in. And I do agree. I think if you do multi-dimension DP or backtracking, I think that's a category you seem like you can improve in. Um, and then once you're like, I just want to do harder questions, I don't really have a particular topic, then I would just go based off of like difficulty. So I think actually I watched something yesterday where someone was saying like figure out like kind of what rating you are ish based on this thing, uh, and then try to do problems around there, or maybe like 100 points higher to challenge yourself. And you can just do random problems, and then you can keep going like higher and higher and higher. And I think you always want to do stuff that challenges you and doesn't like,
Mm.
if it's all too easy and you could do every problem in 10 minutes, you're just not doing stuff hard enough. But if you can't solve anything, then you're going way too far. So try to find kind of like I'm really critically thinking, but it's not like impossible. Um, and then yeah, once you recognize topics that you are really weak in, like DP or maybe some graph thing, just do that one topic over and over and over until you feel like you're good at it. Because
Okay.
if you're
Okay.
really weak in DP and you do random problems, you might get one DP problem every like 10. and then it's not really the best. So that's how I would kind of structure it. If you find an algorithm or data structure you're weak in, just only do that, like focus learning, and then otherwise go back to random problems that are always right. That are always a little bit challenging for you, that you have to struggle and that aren't just like a 5-minute solution. That's why I don't really like the dailies. I think I said this a lot. In the dailies, a lot of times you'll get an easy or something, and then some days you'll get like some insane stuff. So it's not really like targeted practice in my opinion. It's just like all over the place. So yeah.
Yeah, I'm also coming to the weekly contest. Yeah, I'm just because we just want the randomness, right? Like
Yeah,
in
you can
order to
definitely do
cover
the
all the
weekly
topics.
contest. I think that's okay. You can definitely do. I think if you do the weekly contest, I mean, it does different stuff. I do think they ask questions. Obviously, they're going to ask you stuff you haven't seen before. And then the Q4s on the weekly contest are very random. Sometimes they're like extremely hard. And then, do you want to do that? Up to you. I got a lot better, I'll say, and this is a lot of work, by upsolving the super hard Q4s where I just didn't know anything. I was like, I'm not even going to try to code it. I'm just going to look at solution, learn this thing, and then and this was like significantly above the skill level I was doing, and I feel like that helped me a lot. But it's a big time investment, so I'm not just going to say go do that. If you have time, if you want to, sure.
So you're just suggesting me to choose a topic and master it, and then go to the next topic. That's how the better way to learn, right? Like
Yeah, so I would say, like if you've done 500 problems, you've probably done all the topics, right, or most of them.
yeah, yes.
So figure out the topics you're weak in, do a bunch of problems in those. And once you feel like you're okay in everything, then go back and do random problems. And if you notice again, like, okay, I'm doing these random problems and this one topic I just can never do and everything else I'm doing very well, then spend time and do that one topic. And if you're learning a new
Okay.
data structure, like for example, I was once again, this is like not completely not necessary, but like I was learning like segment trees, and I haven't done it in a while, and I was like, I need to make a segment tree with an array, and I need to use this because I'm trying to do like code forces and some other stuff. But this can involve, let's say you learn like Dijkstra's, and you're like, I kind of know how it works, but like every time I code it, it just takes so long, whatever. I would just do like 10 Dijkstra's problems, and then after those 10, you're going to be super good at it. Does that make sense?
Okay. Yeah, yeah.
So yeah, that's kind of the two things: is A, random problems; B, find your weaknesses and just grind those until you get very good at it.
Okay. Other than LeetCode 250 or something, like I just want to get like problems, because in the LeetCode it's like ocean of problems. I can't categorize the problems very well, like
Yeah,
which one
so
I need to
that thing I
solve.
linked to you has a difficulty thing. So kind of figure out what difficulty rating you're comfortable with, and then you can just do random problems from there. That has like the entire LeetCode list sorted by difficulty. So I think that's a good way to do it.
Oh, okay.
Yep.
Yeah, that's it from my side, and thank you so much for your time.
Yeah. Okay. No problem. See ya.
Yeah, thank you. Have a good day.
You too.